So hello everyone, welcome to our new video. So this video is going to be the continuation of the previous videos that I have made on graphs, okay, and the implementation of graph using adjacency matrix, right? So this is the next way of implementing it, the other way of implementing it, which is called as by using adjacency list, okay. So now how are we going to store this entire thing here, right? So here we are going to store this entire data, which will be a map along with a list, okay. So this map, it is going to consist, as we know that a map consists of two values. So the first part, it will be the source node, a single source node, and the other part will be a list of destination nodes, to which destination nodes we have a edge going from this source node, okay. So this is what we are going to use to store the entire data, okay. So now let me just show you a example on it. So suppose if I have these four nodes here, 0, 1, 2 and 3, and I have here directed edges 0 to 3, 1 to 3, 2 to 3, 0 to 1 and 1 to 2, okay. So this is a basic graph that we have here, okay. So now let's just make a adjacency list. How are we going to do this? So what are all the different edges here? We have 0, 1, 2 and 3, and for all these edges I just have to look that where they are going, okay. So from 0 it is going to 1 and 3, so it will have a list of 1 and 3, okay. Similarly from 1, if we check, from 1 we have edges to 2 and 3, so 2 and 3 here. Then if I look at the edge 2, from 2 we have only one edge coming here to 3, and then from the node 3 we don't have any edge going to any other node, so it will remain an empty one. So this is the basic implementation, how we are going to implement adjacency list here, okay. So this was a directed graph. Now if you ask me that how we are going to do this for an undirected graph, right? So this is a basic undirected graph, right? So where do we have all the edges here? We have an edge from 0 to 1, then an edge from 1 to 0, then 0 to 3, then 3 to 0, then also we have 1 to 3, 3 to 1, then 1 to 2, 2 to 1, and then at last we have 3 to 2 and 2 to 3, right? So we just have to implement all of this into a list. So from edge 0, 1, 2 and 3, we have all the edges here. So from 0 we have to 1 and 3. So here it comes as 1 comma 3. From 1 we have edges to 0, 2 and 3. So here we are going to write 0, 2 we have and 3 we have here. So 0, 2 and 3. If I look at from the edge 2, so from 2 we have 1 and 3 here. So 1 and 3 done. And similarly from 3, if I check, from 3 we have 0, 1 and 2. So 0, 1 and 2. Done. This is it. This was simple, right? Implementation of graph using adjacency list in case of directed and undirected graph. So now you would be saying that very cleverly I just finished up with unweighted graphs. Now what about weighted graphs? So just have a look at how are we going to do the same thing in case of weighted graph also, okay. So here we have a weighted directed graph, right? So in case of weighted directed graph, instead of storing a list of numbers, we are going to store list of pairs, okay. Now list of pair as in that pair it will be having two values. The first one is, we all know that the destination node, and along with that the other value in the pair, it will be the weight, okay, of that particular edge. So similar to the previous one we have this. So here where do we have all the edges? We have an edge from 0 to 1 which has a weight of 7. We have an edge from 1 to 2 which has a weight of 2. We have an edge from 0 to 3 which has a weight of 3, and then we have an edge from 3 to 1 which has a weight of 9, right. This is done. The same thing implement here as a pair. So for 0 we have a node to 1 which has a weight as 7, done. And then we have another node to the edge 3 which has a weight of 3 here. So this is also done. Then let's look for the edges from 1. So from 1 we have an edge going to 2 which has a weight as 2 here, and then so from 2 we don't have any edge, so this is going to be remaining as blank, and from 3 we have an edge to 1 which has a weight of 9. So this is done here. Okay, we have 4 edges and here we have 4 pairs of numbers. Clear? So this is how we are going to do the implementation of directed weighted graph using adjacency list. So this is all for this video. In the next video I will be showing you that how we are going to do the implementation of this in C++. Okay, so if you have any doubts or any questions, you can give us a comment in the comment section. We will definitely get back to you. And if you have liked the video, then please press the like button, because that gives us a motivation to record a new video every time. So if you have not subscribed to our channel, then please do subscribe to our channel, and don't forget to press the bell icon so that you get a notification whenever we are uploading a new video. Thank you and keep learning.